Imagine looking up, and instead of a comforting yellow disk, you see a terrifying, swollen red star taking up half the sky. One day, our sun will expand and consume the very planets that orbit it. Right now, that seems impossible. Our star is in the prime of its life, acting as the ultimate engine that drives every weather pattern, ocean current, and living ecosystem on Earth. It is an absolute behemoth. The sun accounts for 99.8% of all the mass in the entire solar system. You could crush together every planet, moon, and asteroid, and it would still barely register against the bulk of our star. It generates so much energy that its light travels 93 million miles across the freezing vacuum of space, taking a full 8 minutes just to reach our atmosphere. Yet, for all its size and power, the sun is a physical machine. And like any machine running on a finite tank of gas, it has a hard expiration date. To understand how the sun will die, we have to look at how it was born. About 4.6 billion years ago, there was no solar system, just a massive, freezing cloud of swirling cosmic dust and gas. Gravity pulled that material together until the crushing pressure at the center generated unimaginable heat. The core ignited, turning that dusty cloud into a massive nuclear reactor. Inside that core, temperatures sit at 27 million degrees Fahrenheit. That is hot enough to smash hydrogen atoms together to create helium, a fusion process that releases a constant explosive burst of energy. This creates a constant tug-of-war called hydrostatic equilibrium. Gravity tries crushing the star's mass inward, but explosive fusion pressure pushes back. As long as hydrogen burns, these two forces hold a steady rhythm, keeping our star intact. But the core is burning through 600 million tons of hydrogen every single second. The fuel gauge is dropping, and eventually that delicate balance will break. According to NASA calculations, the sun has enough hydrogen left to keep burning steadily for roughly 5 billion more years. But the exact moment that primary hydrogen tank runs dry, the fusion process at the center of the sun will begin to sputter and slow down. Without outward fusion pressure, gravity wins. The dead core shrinks rapidly. Paradoxically, this collapse creates intense friction and heat, which radiates outward. This causes the sun's outer layers to balloon and cool, shifting from yellow to deep red. The sun will officially enter its red giant phase. It will swell to over 100 times its current size, creating a monster star that dominates the center of our solar system. The very physical mechanics that sustained life on Earth for billions of years will become the exact mechanism that destroys it. As the red giant expands, it will completely engulf Mercury and Venus, instantly vaporizing their rocky surfaces into gas. Here on Earth, the horizon will be entirely consumed by a wall of red plasma. The global temperature will spike exponentially. The increased solar radiation will strip away our atmosphere. The oceans will hit a rolling boil, escaping into space as a thick cloud of steam. What is left behind will be a dry, cracked, and totally uninhabitable rock. Earth will look like a hotter, deadlier version of Mars. If humanity, or whatever our descendants evolve into, still exists 5 billion years from now, staying on Earth will not be an option. We will have to pack up and leave. The intense heat from the red giant will actually thaw out the frozen edges of our solar system. The icy moons orbiting Jupiter and Saturn will melt, potentially forming new liquid oceans that could host floating settlements. Ultimately, to survive the death of our own star, we will have to outrun its physical expansion, chasing the retreating habitable zone out into the deep dark. The bloated red giant phase is spectacular, but it is incredibly unstable, lasting only about 1 billion years. Eventually, the sun runs out of secondary fuels to fuse. In its dying act, it pulses violently, explosively shedding its outer layers entirely. This expelled material forms a planetary nebula. It is a stunning, glowing shroud of gas and stellar debris drifting out into the surrounding galaxy. Once the dust clears, all that will be left at the very center is the exposed, dead core of our star, a super-dense ember known as a white dwarf. This image shows a direct comparison. Without the outward pressure of fusion, gravity will crush a massive portion of the sun's original mass into a sphere the exact physical size of the Earth. It will no longer generate new energy. The white dwarf is essentially a glowing tombstone, radiating residual heat for trillions of years in the spot where the sun used to be. The solar system will be unrecognizable. The inner rocky planets will be gone, while surviving giants like Jupiter will orbit a tiny, cold, and incredibly dim pinpoint of light. We know this scenario is possible because astronomers at the W.M. Keck Observatory used a technique called microlensing, where gravity bends light, to discover an actual Jupiter-sized planet orbiting a dead white dwarf in our own galaxy. Our sun's timeline is majestic. It started as a swirling cloud of cold dust, ignited into a life-giving engine, and will eventually swell into a terrifying giant before resting as a dense, quiet ember. None of us will be here to see it, but the planets we know so well will one day watch their star change forever. If you were in charge of saving humanity 5 billion years from now, which outer planet or moon would you build our new settlement on? Let us know in the comments below.